All right, today what we're gonna do is we're gonna go through and we're gonna review for our benchmark that we have coming up. We're just gonna get into this. We have a bunch of different things that we have to cover. So stay with me, bear with me, whatever, and let's get started. Okay, so first things first, all our properties. So we've gone over all these properties multiple times, but we need to make sure that we have these so that we can identify them, whether they give us the name of it or they give us the expression of it or whatever, so that we can go back and forth between the two. So when you see it, you need to be able to go, oh, they used associative property right here, or they used commutative property right here. So they're gonna ask you to either give you this and then identify this, or they're gonna give you this and tell you to pick out which one it is. So you gotta be able to go back and forth. So here we go. Associative property, remember, it's the one with parentheses and it's grouping. They changed the grouping. Now be careful with this one because they can put commutative property in there, but associative property, it's gonna have to have parentheses in order for it to be associative property because it's grouping. So take a look. Parentheses x plus 2, parentheses plus 4, and then they move those parentheses and they change the grouping. So x plus, and then they group these two things together. Okay, so be aware of that. They actually moved the parentheses and put a different grouping in there. Okay? That's addition, that's multiplication, and I set these up so that you can see all of it real quick. A times B times C, and then they regrouped it and did B times C first. Remember orders of operations and the way that works. Times A. Okay, so that's your associative. It's about grouping. Be aware of that. Then you have commutative property, if I said that correctly. Commutative property is order. Okay, it's about the order of things. They'll actually switch the numbers around, change the way that it's ordered. Okay, so A plus B equals B plus A. A times B equals B times A. See how they switch the order here? That's what that's about. Now be careful because what they'll do is they'll put them in parentheses and then they'll make it look like it's associative property, but really it's commutative. Okay, so be careful. Look at what they're actually doing. Look inside the parentheses, see if they switch the order inside the parentheses. They'd like to do that stuff. All right, distributive property. Remember, this is always going to have parentheses and it's always going to be the number outside of it. Sometimes it'll be in the front, sometimes it'll be in the back, but it doesn't matter because all they're doing is taking this number and multiply it times things inside those parentheses. So they're going to take 2 and multiply it times x, and then 2 and multiply it times 3. Okay, so that's what they're doing. This number times each term inside of those parentheses. All right, remember, terms are separated by addition and subtraction. So 2 times x, 2 times 3 gets me 2 times x plus 2 times 3. So sometimes it'll look like this, and then sometimes it'll look like this. Well, 2 times x is 2x, and 2 times 3 is 6. So be aware of the different ways that it's going to look. Okay? Be careful with this. Lots of people like to mess this up by just doing this times this, but not times the 3. This gets multiplied times each term inside of there. All right, that's the distributive part. We did that a lot, so we should be good on there. All right, then we have zero property. Now people like to get these two mixed up, zero property and identity of addition. Zero property is when you multiply a number times 0, you always get back 0. Okay? Identity property of addition is when you add a number to 0, you get that number back again. So zero property, multiplied times 0, you get 0. Identity property of addition, 2 plus 0 gets me 2. Identity property, I like to say that you get the identity of that number back. Good way for me to remember. Identity of multiplication, 2 times 1, got 2. When you multiply a number times 1, you get that number back. These two you've been doing since grade school. Don't mess them up. Actually, all 3 of these you have been. You just didn't know what they were called. Zero property, identity of addition, identity of multiplication. Be careful with those. All right. So now we get them over here, and we're going to go through this fast because I don't want to spend a ton of time on things that you should know. Exponents. All right, so we got a whole bunch of exponent rules. We have we have product of power, quotient of power, power to a power. All right? And then you have, how do you write it in expanded form? How do you write it in exponential form? So these are the things that you need to be able to do. All right, so here, exponents 4 to the second power, all we're saying is, well, how do you do this? What does this mean? Well, 4 to the second power means 4 times 4. 4 times 4. Okay, that's what that means, which is 16. Okay, that's what it's meaning. Don't do 4 times 2, that's the common mistake. It's 4 times itself. So 4 times 4 gets us 16. All right, so there's that. Now, you have expanded form. 2 exponential. Expanded form, 2 exponential. So it is in expanded form right now. This is where it's all the way written down on all the multiplication and how it goes. We want to write it in exponential. That's kind of like this. So we're going to take this and we're going to do that. Now, in order to do this, I need to know my product of powers rule. When you multiply a number times, when you multiply exponents with the same base, you just add the exponents. Well, all of these have an exponent of 1. So I'm just going to add them all up. So 3, so there's 1, 2, 3, 4. So there's 3 to the 4th. And then I'm going to do the same thing. 1, 2, 3, 4, 5. X to the 5th. 3 to the 4th, x to the 5th. That's exponential form. There's not a lot to this, guys, but be careful with it. Okay, so here, just moving right along. This is the same thing. It's a product of powers. Except now you have a coefficient in front of it. So we're just going to multiply this times this. Well, you can rewrite this to look like this, 2 times 6 times a times a, because it's all multiplication, and I get to go back over there and use my commutative property. So now I get to do that. Well, 2 times 6 is 12. A times a, well, we just did that up there, so a to the 2nd. Not a lot to this. Don't mess that up. Be careful with it. All right, so now we come down here, and we have 4 to the 2nd power equals 16. Well, we just did this up here, so we know that's true. It means 4 times 4 equals 16. Then, so if this is true, then the square root of 16 equals, well, you got to know what square root is. The square root is just taking a number and saying, hey, what do you multiply times itself to get this number? All right? This undoes this. That's the key here. That's what they're looking for. They're looking to say, do you understand that this undoes this? Well, the square root of 16 should equal 4. Because 4 times 4 gives me 16. That's all that they're trying to do. Do you understand that the square root undoes the square root? That's what we're looking for there. All right. So that's exponents. That's what you really need to look for. The other thing about exponents is realize that when you multiply a power, when you raise a power to a power, you multiply those exponents. I don't remember if that's on there, but I'm going to show you that real quick. 3 to the 2nd raised to the 4th, you multiply these two. Okay, 4 times 2 is 8, so you get 3 to the 8th. Okay, so just in case that's on there, I don't remember, so throw that in there. All right, scientific. Scientific notation is just a way to write really large numbers or really, really small numbers. It makes it easier to write them. It also makes it easier to compare those numbers. So that's what scientific notation is used for. So here we have standard to scientific, and you have to be able to do this. So you need to be able to go from standard to scientific, and then from scientific to standard. So that's what we're looking for here. So here we have it as standard, which is just the normal way that you see numbers, and we're going to take it into scientific. So I have 0.0032, and I want to write it as scientific. Now all I'm going to do is I'm going to move this decimal. 1, 2, 3. Now why do I put it behind that 3? I put it behind that 3 because we want our number to be between 1 and less than 10. Well, if I put it between that 3 and that 2, now I get this 3.2 number. Well, that number is between 1 and less than 10. As long as it's there, I'm good. But I'm always going to be multiplying times a base of 10 times 10, and then I need to look. Was this a really, I need to count. 1, 2, 3, so I counted 3 times 10 to the 3rd, but now I look back over here at this number. Was this number, the absolute value of it, a small number? Was it below 1? If it was below 1, this becomes negative. If it was above 1, that stays positive. Okay, so be aware of how that works. 0.003, the other way that you could look at it is that you moved it to the right, so that's negative, and then had you moved the decimal to the left, that would have been positive, but be careful with that because when you go from scientific back to standard, then it kind of changes all of that, and I don't have one of those on here, so I might need to do that. All right, scientific to standard, yeah, I don't have one of those on there. We're gonna jump down here and then I'll come back to this one. I'll put one up there real quick. Yeah, so 3.0 times 10 to the 4th and 3.0 times 10 to the 7th. This is multiplying scientific numbers, okay? Yeah, I missed that. So we're gonna do this real quick and then I'll do one of those. So multiplying scientific numbers. All you're gonna do is remember that this is all multiplication. If it's all multiplication, I get to reorder it. So I can do 3 times 3 times 10 to the 4th times 10 to the 7th. See how that works? Because it's all multiplication. I get to use my commutative and associative properties to rearrange and regroup. Well, 3 times 3 is 9 times, because it's still in scientific notation, times 10 to the 11th. Okay, so I got 9 times 10 to the 11th. All right, so let's actually just take this number since I have it here. 9 times 10 to the 11th, and let's change this to standard. So I've got this 9 times 10 to the 11th, and we're gonna convert it. So I'm gonna put this up here just because I know I'm gonna need some room here. 9, and then 10 to the 11th here tells me I'm gonna move the decimal that's here 11 spaces, and I know that this is gonna be a really big number because that's a positive number right there. So I'm gonna move it to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, if there had been a number in here, I would leave those numbers and then after that I would fill in zeros. But because there's no numbers in here, I'm just gonna fill in zeros here. 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, and 0. And now my decimal is down here at the end. Okay, now I've taken it from scientific to standard in that go right there. Okay, but who wants to write this all the time? That's why they came up with this. All right, that's all there is to that. Going from scientific to standard, really not a big deal. All right, 3.2 times 10 to the 3rd gallons of water per year to fill a pool. So they do 3.2 times 10 to the 3rd gallons to fill a pool, and then they come in here and they go, how many gallons does it take to fill 5 pools? Well, this is multiplication. All you're gonna do is take this number and multiply it times 5. And really what you're doing is this 3.2 times 5. Because you're still gonna leave it in scientific notation. So off to the side here, let's do that. 3.2 times 5, 10, get 1, 15, 16. So now I have 16, because I moved my decimal right there. So I have this 16.0 times 10 to the 3rd. But this is not in scientific notation form. It's not in scientific notation form because this is not between 1 and less than 10. So I need to take this decimal and I need to move it a spot. 1 there. So 1.6 times 10, and I'm going to move this from 3 to a 4. To 4. Had I moved it to the right, I would have taken that down. But I moved that to the left right there, so I moved that up. Be careful, really easy to make a mistake right here whenever you're raising or lowering this number. So be careful with it. So 1.6 times 10 to the 4th. It's really not that hard, but it's an easy mistake to make. Okay? Be careful with it, be careful. All right, so that's most of scientific notation right there. If you're in 8th grade, calculator will do most of it for you. Make sure you know how to switch between modes. Make sure that you know that when you're multiplying, you put the parentheses where they go, or if you divide, you put the parentheses right where you go, because otherwise your calculator will do it according to orders of operations, so be careful with that. Okay? All right, so moving on. Rational and irrational. All right, so we have rational and irrational, and what you need to be able to do is identify numbers that are rational and numbers that are irrational. So you gotta be able to do those things. Okay, so here, I got a list of numbers up here, and you're gonna have to be able to go, hey, that's a rational number, that's an irrational number. You should be able to identify between the two. All right, now remember that a rational number can be written as a fraction. An irrational number is a never-ending, never-repeating decimal. All right, so that's the difference between the two. And remember that if you have a rational number, you do not have an irrational number. Or if you have an irrational number, you do not have a rational number. They're different. Okay, so here I have 3/4. Well, that's a rational number. Okay, so this is a rational number because it can be written as a fraction. It is a fraction, 3/4. Okay? Square root of 64. Well, just a minute ago we did square roots and we knew that what that really means is what number do you multiply times itself to get this number? Well, the square root of 64 is 8. Well, 8's a whole number, so yeah, that's rational. We're good there. Okay? Well, what about pi? Well, pi is that number that we put in for surface area, cylinders, circles, things of that nature. We use it there. And we always use 3.14, but in reality, that's not the number that it is. That's an estimation of what the number is. Pi, in reality, is 3.14, I think it's 15, but whatever, it goes on forever, never ends, and it never repeats. Oh, that's an irrational number. Okay, that is an irrational. Never ends, never repeating decimal. Never ending, never repeating decimal. Okay, well, what about this? 8.252525 ... Oh, well, we're repeating here, 252525. Another way that this could have been written was this, like that. So be aware of that. Well, an irrational number is a never-ending, never-repeating number. Well, that repeats. Well, if this repeats, that's not an irrational, so it must be a rational. So this is a rational number. The other way that they could write that is they could write it as the fraction. I believe it's 1/4. 8 1/4. Right? No. Yeah. 1/4. Am I wrong there? 8.2525. No. Because that's not, that's repeating. It's 25 over 9. 99. 8 and 25 over 9. I was trying to do 8.25. Yeah, that's an easy mistake to do too. 8 and 25 over 99 because this number is repeating. Yeah, be careful with that. But it can still be written as a fraction. Yeah, I try to get cute. All right. Square root of 8. Again, what number can you multiply times itself to get 8? Well, there's not a number that you can, well, there is, but it's an irrational number. What you do with this is you pick up your calculator and you plug in the square root of 8 and you hit enter because it'll give you this. But if it doesn't, if it comes out to a decimal, like it will, you know you got an irrational number. If it's a non-perfect square, that's what you're looking for, a non-perfect square. So I know that there's not a perfect number or a whole number that I can multiply to get this. Therefore, I know that's irrational. So this is irrational. Okay, that's what you're looking there. All right, so now I have -8. Okay. Well, that's just an integer, guys. It's an integer. And if it's an integer, it's a rational number. Okay, so here we got a rational number. That's all there is. You should know what that is. All right, 2.27282930 ... Okay, so this looks like it repeats, but it doesn't. Watch this. This is the type of question that the people like to put on tests. 2.27, 28, 29, 30, dot, 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 dot. 27, 28, 29, 30 does not repeat. It's a pattern, but it doesn't repeat. And it never ends, so it's got these dots out here. That is an irrational number. Okay, that's all there, that's what you're gonna have to be able to do, identify it. Okay, just remember that here, if it's repeating, it's rational. Here, not repeating and never ending, irrational. Perfect roots, rational. Non-perfect roots, irrational. And then watch the others that they just like to throw in there to mess with you, and then pi is always irrational. All right, so let's talk a little bit about the way that when you combine these different types of numbers that they work. If you have a rational plus a rational, rational minus a rational, rational times a rational, rational divided by a rational, all those are rational numbers. You will get back a rational number. So remember, if they put two rationals together, when you get the number back, it's going to be a rational number. That's what this is talking about. So they're all equal a rational number. This right here is something you just have to memorize to understand. I mean, you could plug in numbers, but memorize it. All right, so here, when you do this, an irrational and a rational together all equal an irrational as long as the rational number is not 0. All right, so all of these, you're going to get back an irrational as long as the rational number doesn't equal 0. Because when you multiply a number times 0, you get back 0, which is a rational number. That's really how that comes down to. Okay, so you have that. Be aware of that. The other is when you do an irrational and an irrational, flip a coin. Sometimes you're going to get irrational, sometimes you're going to get irrational. It all just depends on what you're doing, what the numbers are, and what operation you're doing. So one time one way, one time another way, but you got to be aware of that and know how to do that. All right, so now we're going to move into substitution. Guys, substitution, we've been doing that since the beginning of the year. Here's our number, -12 plus 3 times x minus 2, parentheses. And then they come over here and say, well, x equals -2. So all we're going to do is we're going to take this number and place it in the value of x. Anywhere there's an x inside of our problem, that -2 is going. And it is the -2. A lot of people are wanting to just put the 2 in there, but the -2 is what's going in there. So here we go. -12 plus 3, parentheses, x, -2, minus 2, parentheses. Now we're just doing orders of operations and watching our sign rules. All right, orders of operation tell us to do parentheses first. We're going to go inside the parentheses, -2, minus 2. I'm going to do click, click right here. And then I'm going to put them together. So I'm going to rewrite the problem. -12 plus 3, parentheses, -2 plus -2 gives me -4. And then I'm going to take -4 times 3, 12 plus, there gets -12. And now I've got a -12 plus a -12. Well, remember your sign rules. A negative plus a negative, you just put them together, keep their sign. So, -24. Don't miss substitution problems, because you can do them. Just watch your sign rules, watch your orders of operations, make sure you fully substitute. If you do that, you're going to be just fine. Okay? Substitution you should be able to do. All right, so here's surface area, and we just got through doing surface area and volume, so you should be pretty comfortable with it. Remember, surface area is just substituting into a formula. All you got to do is find your formula, which you'll be provided a formula sheet. All you got to do, substitute the numbers correctly into the formula. So first thing we're going to do, we're going to find the surface area this way. So here's our formula. Surface area equals 2 length times width plus 2 length times height plus 2 width times height. Now there's another formula that's on your formula sheet, but I felt like we'd be more comfortable using this one, so we use this one. Later on when you get into geometry, they're probably going to teach you the other formula. and, cause I would. All right, so here we go. 2 length, and when you're talking about the total surface area, you get to pick which one goes for the length, you get to pick which one goes for the width, and you get to pick which one for the height. But once you assign it, you need to keep it that way. So here, length, width, height. Let's say length is 6. Let's do height as 12, because most of you guys like the bigger number as your height. And then I gotta determine, because I'm only given 2 numbers here, I gotta determine what that other number is. Well, when I do this, I'm looking at the way that this box will fold in to determine what my other number is. So I know that if this is 6, this is 6, this is 6, this is 6. Pretty straightforward. I know that if this is 12, this is 12, this is 12, this is 12, this is 12. And then I've got this other side here. So this must be 6. These 2 are where that box folds up and meets that corner. So that's my other number. So I have the other 6 there as my other number. So now I'm going to just take these, substitute it in. 2 times 6 times 6 plus 2 times 6 times the height, which is 12, plus 2 times 6 times 12. All right, and I just, width, length and width. So I've got 2 of these that are the same. So I've got 6 times 6, which is 36, times 2, 72, plus, I don't remember what that is, so I'm gonna do that. 12 times 6, 72 times 2, 144. All right, so 144 plus 144. And now I'm just going to add those 2 or those 3 together. So 144 plus 144 plus 72. All right, so plus 72, 360 centimeters squared, because when you're talking about area, you're talking about how many 1 by 1 squares fit along the outside of that. I lost it. Shape thing. Shape. All right, so that's what you're talking about. All right, now we're talking about volume. Volume has 2 formulas here. All right, one of them is length times width times height. The other is base area, or the area of the base, times height. Now, if I'm given this, I'm going to do length times width times height. But it's really the same thing, because the base on this is a rectangle, which is length times width, if I want the area of that. So these 2 things, really the same thing. They all come back to length times width times height. Okay, so we're just going to use this to get this. And now I have length times width times height, and I'm good. So I'm just going to multiply these out. 6 times 6 times 12. And I'm going to use the calculator to speed it up a little bit. 6 times 6 times 12, which gets you 432 centimeters cubed. And it's cubed because what it's talking about is how many 1 by 1 by 1 cubes I can fit on the inside of that shape, that prism. Okay, so that's what it's talking about. How many 1 by 1 by 1 cubes go on in the inside of it. So volume is about the inside of it and how much it is. All right. Well, sometimes what they'll do is they'll give you something that looks kind of like this. Now this is a rectangular prism where they've shaded in one side, and then they've got one side that is labeled as just inches, and the other is inches squared. Well, this inches squared right over here is a good indication that they've given you the area of this side. So that's what they've done. Not only between the being shaded, but being that, now you understand that, oh, that's the base area. So they've given you the area of one of the sides, and all you have to do is multiply it times this other number here. So I'm going to multiply those together, 3 times 20, so you get 60 inches cubed. And that's what they're doing here. And this one goes with that, and this goes with this, okay? But be aware that they'll do this to you too. They'll give you that little shape there, and a lot of times they're gonna give you this, but on occasion, every now and then, they're gonna give you this to see if you understand that this formula works also. Base area times height, because that's what that is. That's base area. All right, so we got one problem left, but really it's two. Surface area and volume of a cylinder. So here we have a cylinder, and I'm gonna shut this door real quick. Sorry, I heard someone out there. All right, so surface area and volume of a cylinder. Now, the first thing we're gonna do is look at the shape. Yep, it's a cylinder. Next thing we're gonna do is look at the numbers to make sure we know what numbers we're given, okay? Important thing is we need to have the height and we need to have the radius. If we have those two things, we can discover what the surface area is, what the volume is. So that's the first thing we're gonna do. So what are we given? Well, here's the height, 10. Okay, so the height equals 10. And then right here, well, here's the base, right? The circle of the base. Well, that's 12 and it goes all the way across. Well, that's diameter. When it goes all the way across, that's diameter. So 12. Well, the radius is half of the diameter. Radius equals half, which is 6. Okay? So now that I have all of this, now I can take all of this and I can substitute it into all of these. It really is just substituting into a formula. Now, there's two different ways that you can do this problem. You can leave pi as the symbol in there, or you can take and do substitute in 3.14 into pi. They both work. They'll both get you the same point. Just read the problem and make sure you understand what they're asking you to do. Because most of the time, they're going to tell you, use 3.14 for pi. So either way, I'm going to leave the symbol in there at first, and then at the end, I'm going to substitute in 3.14 so that you can see how that's done. I think most of you are really comfortable just putting 3.14 in for pi and going from there. And that's perfectly acceptable. So we're going to do that. So 2 pi, or, which is 6, so 2 times pi times 6 times the height, which is 10. All right, so this little first part, remember that's your LSA, that's your lateral surface area, that's this part right in here, okay? Plus 2 pi radius squared, 6 to the second power. All right, so here, now all I gotta do is multiply them together. 6 times 10 is 60, times 2, 120 pi. Remember, computer probably lets me reorder this, so I can do this right here because it's all multiplication. So 6 times 10, 60 times 2, 120, and I still have it being multiplied times pi, so 120 pi. Plus, now here, I've got to do this first because of orders of operations. Exponents first, parentheses, then exponents. So 6 to the second power, which is 6 times 6, gets me 36, times 2, 72 pi. Now, combine like terms right here. So they have the same variable, raised to the same exponent, so I can add them together. So here, I've got 192 pi. And from here, now I'm going to take 3.14 and I'm going to substitute it in for pi. Now, the good thing about this is that if I do it this way, every now and then they leave the number like this. This is called terms of pi. And it would be inches squared because it's surface area. So sometimes they'll leave it just like this and you're good to go if you do it this way. Other times they put pi in. So 192 times 3.14. And multiply those together. And again, I'm going to use the calculator to make it a little bit quicker. 192 times 3.14. And you get 602.88 inches squared. And it's squared again because we're talking about the 1 by 1 squares going along the outside. And it's total surface area. Now remember, this part right here, that's your base area. That's the area of the circle. And you multiply it times 2 because you have the top one and you have the bottom one. Okay, so there's that. Now, let's take the same number and you do volume. And this time, I'm gonna do 3.14 in for pi so that you get to see how that works. All right, so volume equals pi r squared times h. And again, I'm gonna substitute in 3.14 for pi right off the bat. So 3.14 times the radius squared, well, our radius was 6, so 6 squared times h, which was 10. Okay, so now I have it all substituted, and all I have to do is start putting it together. So 3.14 times 36 times 10. I'm going to go ahead and do this multiplication just to make it a little bit easier. Times 360. And now I'm going to do this multiplication here. And 360 times 3.14. 1,130.4 inches cubed, because we're talking about how many 1 by 1 by 1 cubes you can fit on the inside of this cylinder. Okay, that's how to do all of these. You got to see one with 3.14 automatically, one without it. They both work and they do the same thing. I know this has been a pretty long video, but that's really most of what you need to have for the benchmark review that we have coming up. If you have any questions, you need anything, let me know. We'll try and help and do our best.